Today we are going to cover the circumference and area of circles. We're going to start with circumference. Here we're going to understand exactly where pi comes from and the relationship between pi, the diameter of a circle, and the circumference of a circle, which is the perimeter, the distance all the way around the edge of the circle. As I play this video, notice that we're tracing out that blue diameter comes to the outside, then the yellow diameter goes to the outside, now the pink diameter goes to the outside, leaving behind just a little bit extra. 3 diameters plus a little bit extra equals the perimeter of the circle. So in this circle, the diameter is 9.32. It took 3 of those plus 1.32, which as a fraction of the diameter is 0.14. So 3 diameters plus 0.14 diameters equals my circumference. If I factor out the diameter out of that, I'm left behind with 3 plus 0.14, which is pi. So pi times my diameter equals the circumference. We also know that the diameter is simply equal to 2 radii, so I can say that this diameter is 2r, and all we have to do is rearrange this formula to the way that we are used to seeing it, which is always constants first, then irrational numbers, and then lastly variables. Circumference equals 2 pi r, but to say circumference equals pi d is totally appropriate as well. Here we have a single circle. And inside of this circle, we've shaded the area. So now we're going to shift from the perimeter of the circle to the area inside the circle. We're going to figure out the area formula for the circle by first dividing this circle into eighths. So you can see that I've drawn these lines. And next, I'm going to break all of those little wedges apart and I'm going to rearrange them. Look at how I'm going to rearrange them like saw teeth together. And when I push them together, they turn into this funky shape, which kind of looks like a bumpy parallelogram. But what's cool about this bumpy parallelogram is that one radius right here is almost the height of the parallelogram. It's not, because we still want to make sure that the height is perpendicular, so it's a little crooked. But then when I also look at around the edges, look, I'm tracing out 1, 2, 3, 4 of the wedges. This is half of the wedges. Right there, I can see it. This length right here is half of the circumference. Here's how we're going to use this and make this a little bit more useful. I'm going to divide that circle into even more wedges. You can see that my screenshot kind of cut off the edge of the circle a little bit, but the same thing is happening. Way more wedges, but when I break those wedges apart, put them together like saw teeth, half and half, squeeze them together, and I get this almost parallelogram. Very similar to before, though. I still have the R. I have all of the bumps right here equal half of the circumference. You can compare this shape to the previous one and see that it's standing much more upright, though. It's starting to get closer to looking like a rectangle. Divide the shape even further, and I get even more triangles, and I get even more saw teeth together. But now, R is almost completely upright, and that half of the circumference is still the base of what now is starting to look closer to a rectangle. If we could divide this infinitely into infinitely small rectangles or little wedges, I actually do wind up with a perfect rectangle with R being a nice, perfect, perpendicular height. So when I want to calculate the area of this rectangle, my area is my base times the height of that rectangle. Well, we just figured out a formula for circumference where circumference can be written as 2 pi r. When I plug in the rest of this formula, I am seeing where my area formula is going to come together. Right here, 1/2 times 2, that's just a 1. Those cancel each other out. Right here, I actually have an r squared. Those cancel, there's my r squared, and I'm left with pi. My area formula is pi r squared, which comes from a rectangle made out of the circle, divided into infinite wedges. Check this out. This is my favorite visual proof I've seen. This one's awesome. Watch. And the height is the radius. Circumference again, 2 pi r times the radius. There's my radius squared. Half and 2 cancel out just like before, and just like before I'm left with pi times the radius squared. This time, instead of making a rectangle, I've made a triangle out of it, and I love to see this visual of seeing that circle kind of unwind and turn into a triangle. Please make sure you add these formulas to your notes. If you're not looking at your notes and you're trying to remember which formula is which, one thing I always try to remember is when looking at them so that we don't mix them up is that the circumference formula is a length, and this is in 1 dimension. This is a hidden exponent of 1 right here. The diameter is just not times anything except a number. The radius, it's just there. This is a radius squared times itself. That's 2 dimensions, and 2 dimensions is area. All right. Thanks, guys.